Hi everyone. Today we're going to study location of absolute extrema. Let us study this theorem. Let f be a continuous function over a closed, bounded interval I. The absolute maximum of f over I and the absolute minimum of f over I must occur at endpoints of I or at critical points of f in I. Now let us see how to locate absolute extrema over a closed interval. Given a continuous function f defined over the closed interval from a to b. Step 1. Evaluate the function f at the endpoints x equals a and x equals b. Step 2. Find all critical points of the function f that lie over the interval from a to b, and evaluate the function f at those critical points. Step 3. Compare all values found in steps 1 and 2. The largest of these values is the absolute maximum of f. The smallest of these values is the absolute minimum of f. Example 1. Find the absolute extrema. That means the absolute maximum and the absolute minimum of the function y equals negative x squared plus 3x minus 2 over the interval from 1 to 3. For our solution, let us do step 1, and that is to evaluate the function f at the endpoints. The endpoints are the end numbers of the interval, and these are the 1 and 3. Let us begin with f of 1. So we have here the negative of the quantity 1 squared plus 3 times 1 minus 2. This negative of the quantity 1 squared is simply minus 1 plus 3 times 1 is 3, then minus 2. Simplifying these three numbers, we have 0. The f of 1 equals 0. Then f of 3. And this is equal to the negative of the number 3 squared plus 3 times 3 minus 2. The negative of 3 squared is negative 9 plus the 3 times 3 is 9, then minus 2. Simplifying these three numbers here, the answer is negative 2. So f of 3 is negative 2. Step 2. Find all critical points of the function f that lie over the interval from a to b, and evaluate f at those critical points. Looking for the critical points, first we will take the derivative of the function. So we have now this y prime equals negative 2x plus 3. We can see here that our derivative is a polynomial function, so the derivative is defined in all its domain. Next, let us set the y prime into 0. So we have the 0 equals the right side members of the equation. Now let us solve for x. The positive 3 we will transpose to the left side. We have now this negative 3 equals negative 2x. let us isolate x by dividing the equation by -2. So we have the left side to be -3 over -2 equals x. So the x here is equal to positive 3 over 2. So this is our critical point. Take note that this value is inside the interval from 1 to 3. Next, let us evaluate the function with respect to this critical point. So we have the f of 3 over 2. And this is now equal to the negative of the quantity square of 3 over 2 plus 3 times 3 over 2, then minus 2. Simplifying further, this expression here becomes the negative of 9 over 4 plus 9 over 2 minus 2. In the next step, let us show that we have equivalent fractions of same denominator. So we have this negative 9 over 4 plus the 9 over 2 becomes 18 over 4 minus the whole number 2 is now 8 over 4. Combining like fractions, we have now the final answer to be 1 over 4. So the f of 3 over 2 is equal to 1 over 4. Step 3. Compare all values found in steps 1 and 2. It's better if we can put a table like this. We have two columns. The first column is for the x, and this is the column for the endpoints and critical points. So we have the 1, the 3, and the 3 over 2. And the column f of x, we will write the corresponding values. So we have 0, and this -2, and also the 1/4. Now, let us compare the values of the second column. Which one is the largest? Which one is the smallest? We can see here that the largest is the 1/4, and the smallest is the -2. So we write here that this 1/4 is the absolute maximum, and the -2 is the absolute minimum. In words, we can write like this: absolute maximum of 1/4 when x equals 3 over 2. Absolute minimum of -2 when x equals 3. This is our final answer. Example 2. Find the absolute extrema of the function f of x equals x squared minus 3x raised to 2 over 3 over the interval from 0 to 2. For our solution, let us write the step 1, and that is to evaluate the function f at the endpoints. Here are the endpoints. Let's begin with f of 0. And this is equal to 0 squared minus 3 times 0 raised to 2 over 3. Simplifying this, the value is equal to 0. So f of 0 equals 0. Next is f of 2. This is equal to 2 squared minus 3 times 2 raised to 2 over 3. Using the calculator, the answer here is negative 0.762. Step 2. Find all critical points of f that lie over the interval a to b and evaluate f at those critical points. First, let us take the derivative. The f prime of x is equal to 2x minus 3 times the fraction 2 over 3 times x raised to negative 1 over 3. We can cancel this 3 and the denominator 3. Simplifying further, our function now becomes 2x minus the fraction 2 all over x raised to positive 1 over 3. Let us combine them into a single fraction. So we have now this 2x raised to 4 over 3, then minus 2 all over x raised to 1 over 3. This is our derivative. Now let us set f prime of x into 0. So we have the 0 equals this fraction here. When the derivative is a fraction, we can get a value of derivative when it is equal to 0. Or we can take a derivative when it is undefined. So let us now solve for the x. Let us cross multiply this denominator to the left side. And this will just be 0. So we will have 0 equals this numerator. And solving for x, this negative 2, let us transpose to the left side. It becomes positive 2. From this line here, we can solve for x, and we will find out that the value of x is plus or minus 1. But take note that x equals negative 1 is out of the interval given in the problem. So we will only accept the value of x equals positive 1. Next, given that our derivative here is a fraction, there is critical point when derivative is undefined. It will happen if the denominator is equal to 0. So the x raised to 1 over 3 equals 0. And let us solve for x, so we will have x equals 0. In here, we have another critical point. But we say that the f of 0 was evaluated already in step 1. It means to say, we will only evaluate the critical point when x equals positive 1. So we have this f of 1 now equal to 1 square minus 3 times 1 raised to 2 over 3. This 1 square is 1 minus 3 times 1. This 3 times 1 is 3, and 1 minus 3 is simply negative 2. So f of 1 is negative 2. Step 3. Compare all values found in steps 1 and 2. We can put a table where the first column is x, and this is for the critical points and the endpoints. So we have here the 0, the 1, and the 2. And the second column is for the f of x. So we have 0, negative 2, negative 0.762 respectively. Now, let us compare the values in the f of x. Which one is the highest, which one is the lowest? We can see here that the highest is 0 and the lowest is negative 2. So the conclusion is, we write here the absolute maximum and we write here the absolute minimum. In words, we may write absolute maximum of 0 when x equals 0. Absolute minimum of negative 2 when x equals 1. This is our final answer. I hope you learned something from this video. See you again next time.